Okay, so let me start. Okay, so again, thank Mr. Speaker for Mr. Session Leader for the introduction. So thanks again for being there on a Saturday. So this talk, I'm just going to talk about data and company data. And data is probably the most precious resource of a company, they say. I was talking to a cyber insurance agent the other day, and he was telling me, yeah, data is the most precious resource in a company, because if a company loses its PCs, loses its, you can always replace the PCs. You can always replace the chairs if there's a fire. You can always replace the office, but you can never reconstruct the data if you lose it. So really, data is the most important element companies have. And if you lose it, the company is in serious trouble. So this talk is about, how companies can be sure that data always survives. Now, so how this work started? This work started about 2 years ago. What we see here on the left-hand side is a dentist's office. It's a dentist. Now, it's not my dentist, but on the right-hand side is my dentist. It's the office building. It's the building in Geneva where my dentist has his office. About 2 years ago, on a Sunday, the office went up in smoke. There was a fire. Now, a dentist is like very many small and medium-sized companies, or micro companies as well, is that, managing data is something they do because they have to. They come to the accounting, list of clients, etc. It's not something that is really their main job. And many small companies still, unfortunately, do not know how to treat data, do not know how they should be handling data. And in this case, it's quite serious for the dentist. For example, there are patients who are coming on the Thursday and the Friday for a procedure. The dentist said, well, come back on the Monday or the Tuesday. But on the Monday or Tuesday, there was no dentist's office. So what's important for the dentist and many other small companies is to be able to have when he sets up in a temporary office, to be sure he has access to the data. Now, it's not just because of emergency procedures, emergency situations that we have to protect our data. We know that, unfortunately, that ransomware, for example, is an increasingly big problem for all companies. Security experts tell us that in 2021, the number of ransomware cases is about 3 times more than what it was in 2020. The most common type of attack that companies are subject to today is a ransomware attack. And there are many cases we've heard recently. I mean, big cases, big companies being attacked, the Irish Health Service, for instance, but small companies are also attacked. And it's very easy for a company to be attacked by ransomware. If you go to the dark web, you can hire a ransomware kit now for $15 US. So if you have $15 US, you can hire a ransomware kit and use it to attack some company. So that means, companies, we have to protect our data, okay? And it's not just, also another reason for protecting our data is that we're legally obliged to. Now, for those in Europe, you might be familiar with the GDPR, General Data Protection Regulation, which means if you're storing personal data about a person, and if you're a company, you are storing personal data. You store data about your clients. The dentist is storing data about his patients. If that data gets lost, if it gets exposed after a cyber attack, the company has to show that he has taken the necessary security measures to prevent that attack. Of course, some attacks will succeed, but if the company is deemed not to have taken those sufficient security measures, then he will be fined. Now, I know GDPR is a European phenomenon. It's a European legislation, but similar legislation is appearing all over the world. In Brazil, there's legislation. In California now, there is legislation like this that is appearing. So for all those reasons, So the company has two risks. He has the risk of his data being lost through an incident like the fire, or a hacker, or a security intrusion. And he has the risk of, when the data is lost, that he might be fined because the auditor or the government did not consider that the company took sufficient measures to protect the data. Okay, so sorry, just on a small point, okay, how do we protect data? How do we ensure that data is conserved, that we can always access the data? Well, we do backups. We do backups. We always tell companies, do backups, back up your data, back up your data. Now, the problem with that message, it is important to back up your data, but it's not what we want a company to be able to do. We don't care that a company does a backup. What's important for the company is that he's able to do a restoration, which is a completely different thing, because you try a backup. If it doesn't work, you relaunch the backup operation. But you only get one chance to do a restoration. You do a backup on a Friday evening maybe, but you do a restoration in an emergency situation. And to be sure that the backup works, you have to be able to rehearse that backups, the restoration. So keep in mind, it's not just enough to do backups. It's all about being able to do restorations. Now, so basically, that's what we mean in this talk by recoverability, to be sure that we can always recover the data. So what does this mean in the context of some company? Well, any company, he has business data. I suppose in the case of the dentist, the business data are maybe the Excel files with the patients. It may be the image files which correspond to the radiography of the teeth, because the dentist has a radiographic device that takes a radiography of the person's teeth. It's all the bills PDF files. So he has a lot of core data that he needs to be able to back up. So what should he be able to do? He should be able to make a backup. Now, I use the term backup and snapshot. Backup is just the verb describing the backing up of the data, creating a second copy. And the backed up data, the copy that's created, I call it a snapshot. Okay. So what we want to be able to do is that once the snapshot is created, assuming it's stored somewhere safe, that from time to time, we test the restoration of that backup, okay? And how do we test it? Well, if you're storing an Excel file, from time to time, you restore the Excel file and you open it and you see if all the sheets are there, if the data is still in it. If you're storing an image file, you just copy the image file and you look at the image. Is it still readable? Then it's okay. If you're backing up a database, a MySQL database, for instance, which we might be doing because perhaps your company is managing a web server, a MySQL or Postgres database, then what you do in the test? Well, you're going to restore the database and execute some SQL queries. And you keep doing that. And if at some stage that the snapshot is no longer readable, if the tests no longer work, then you know that the snapshot is no longer usable or the data is no longer restorable. And in that case, you throw the snapshot away, and at least you know in advance that there will be a problem with the restoration. The point is to be able to detect problems with restoration before you need to have to restore the data, before the emergency situation arises. So why do restorations fail? So as I said, it's all about restoration, being able to ensure that your restoration succeeds. Well, a restoration might fail for three reasons. The first reason is that the backup fails. Okay, and a lot of in the literature and a lot of papers describe why backup fails. Maybe you've already come across these type of situations. Your backup operation might fail for technical reasons. Maybe you're creating the snapshot or doing the backup operation on a device where there is insufficient memory capacity. That's something that can happen. Maybe when you do backups, maybe you're using a script, and at some point the script fails because there's insufficient permissions. or a lot of errors like this can arise. Another reason for backup failure is it's people failure. Is that maybe you've delegated the job of doing a backup operation to somebody in the company, but maybe on the Friday evening, if you're doing a manual backup, that person is not there. Or maybe a script, the script. Maybe you're doing backup operations on your vSphere servers with scripts, and some script failed for some reason. It can happen, and nobody is there to check the status of the script. So that's what I call people failure. Now, all of these failures are very common, and if the backup fails, then you don't have a snapshot from which you can restore. So obviously, the restoration will fail. A second reason for restoration failure is that your snapshot becomes unusable. Now, it can happen for many reasons. Maybe you're doing a snapshot, creating your snapshot within the company. Maybe you're using media like disks, external disks or external NAS. If you're storing the NAS and disks in your premises, they can get stolen, they can get damaged. Okay, there can be physical damage. I mean, if you're using disks or then obviously physical damage is a possibility. They can get infected. That's an increasing possibility. And that's the nightmare scenario for ransomware, is that your main data gets infected, but also that the backups are infected too. Another reason, okay, that's for the case where you're storing your snapshot locally, but you might be storing your snapshot on a cloud with a cloud provider, which of course more and more companies do. And when you do that, you're making a lot of confidence in the cloud provider. Cloud providers can go up in smoke. It's rare, but it does happen. I don't know, you might have heard of the OVH case, which is a cloud provider based in, I think it's either Luxembourg or Belgium or around that area of Europe, that went up in smoke earlier this year. But also, if you're using a cloud provider, it means that you need credentials to access that cloud provider. You can lose those credentials. Maybe the cloud provider goes out of service. Maybe he changes his API and the scripts that you're using to get the data no longer work. So the fact that you're using a cloud provider is no guarantee of a snapshot usability, okay? Or what I call survivability. Survivability is just the property that you have a snapshot, and at any time you need to restore data, you have a snapshot available. Now, I use temp snapshot, as I said, it's just the backup of business data. So it's if you need to do a restoration in an emergency conditions, the snapshot is what you're going to be using. I would distinguish snapshots from archives, which are data that needs to be stored long-term, like perhaps a company's tax returns need to be stored over a period of 10, 20 years. These are not data that need to be restored or that are needed. They're not a direct copy of business data. So when I talk about snapshots, it's only for business data that needs to be restored immediately. Okay, so these are two reasons why restorations fail, because the backup fails or the snapshot becomes unusable. Another reason why the restoration might fail is that the restoration operation fails, okay? Now, if I go back to the case of the dentist, when he had to restore the data, it was an extreme example. He had to restore it in a different site. So he went to a temporary office where the machines were not the same. Maybe the versions of the OS were not the same. And the idea is that when you make a restoration of data, you're not necessarily restoring it in the same type of environment or in the exact environment in which you made the copy. And that can cause problems. Now, it's very difficult to have the exact same environment in which you created the data, because in an environment, it includes many things like versions of operating systems, configurations of applications, even network configurations like DNS, NAT. I mean, if your application is using external APIs, then you're going through a DNS server. And if you're using a different DNS server, then that can make a big difference, because when the application resolves a name, it might not go to the same server. So what we want is, the third reason restoration fails is that you're trying to restore the data in an environment in which the restoration cannot be made because maybe there are licensing issues, versions of OSs. Versions of OSs can be a real problem, in fact, or versions of applications. Okay. Now, when I present this work, everybody asks me, well, yeah, okay, but what happened? Is it not sufficient that when you do your backup, you take a digest, a hash of the backup, and to be sure that the data is restorable, you verify the hash from time to time. And this is actually what a lot of companies do. They make a backup, they create the snapshot, they take a hash, and continually they verify that the hash is still valid. But it assumes that the snapshot was created without an error. So really, I want to stress that the only way to check a restoration is to do a restore, and that's I think there's no other way around that. Okay, so what we're doing in this project is that what we want to do is that since we want an approach that's accessible to small businesses, it means being able to automate as much as possible. So that's why in the title there is automated, and there is a lot that we can automate. Okay, now suppose when the snapshot is created, as I said, the snapshot is going to be, in our case, a backup, a copy of an Excel document or OpenOffice. The API is the same, PDF, MySQL or Postgres exports, and flat files are just ordinary directories. Because we feel that this covers more or less the main classes of business data that you will find in most small companies. So the idea is basically is that once you have a snapshot, the idea is to continually verify the snapshot. So basically we will have a script that runs and there will be a test case. I'll come to the test case in a second. Basically these are just commands that interrogate, look at the contents of the snapshot. Okay, and we execute on the snapshot copy, we just execute these commands. Now for Excel files, PDF documents, and flat files, we can just execute the test case directly on them. In the case of MySQL or Postgres database, what we do is we create a virtual environment with Docker, again, a free, lightweight virtual machine, and we execute the test case within, okay? What we call environment 0. It's just a simple Docker environment where we run a Debian Buster Linux, and which opens up the database. It unpacks it, creates the database, and imports the database export into it and runs the tests. Now, with regard to the tests themselves, we haven't completed all automations, but the idea is to do as much as possible automated. For example, if we take a MySQL database, this is an actual test we use. Why can the test be generated automatically? Is that we just randomly choose tables and columns and data within the database and write tests that correspond to that. For example, test world structure test city table, we just assert that some column exists, that a row exists with the city with the value 4,000, that the column exists in the city table with the name, population, etc. Basically, these are the type of tests that a human would do manually if he opened up the database and just was checking around to see that the data seemed to be fine. Similarly, a PDF test is just when you look at a PDF document. The good thing about PDF is that it has a standard metadata, so we could look at the title of the paper, the authors, the page count, the images within the paper, the images within the file, and stuff like that. Again, given if you have a PDF document, you could randomly generate this type of tests, which, so this, as I said, this test can be created automatically. With the test operations in our framework, these are the test operations that we defined. So for example, Excel, we have a search sheet exists, a cert column count. For SQL, we have a cert column match query and expect a certain result in return. For flat files, just assert some directory exists, some file name exists, etc. Of course, if you're a programmer, then you probably, this type of approach sounds very familiar. For example, if you're a web developer, maybe you use Ruby on Rails, which is one of the very popular web development frameworks. With Ruby on Rails, we have AirSpec, which is a test framework, which allows you to generate tests, which generate tests automatically, and which allows you can extend the tests. So the idea here is that tests can be generated automatically and they can be extended manually if you want to, exactly like AirSpec or JUnit if you're a Java programmer. Okay, and with regard to restorability, I said in the basic test framework, just a Docker container is created in which we inject a Linux image for doing the tests. What we can do also to test restorations in different environments, because maybe you're going from one version of Postgres to a new version. Maybe you've changed a version of Linux and you're using different libraries and you want to see it as your test. Can you restore your data in that new environment? The way we model that in Docker is that when you create a Docker container, you can link a folder in the virtual machine, in the container's virtual OS, to a folder on your own machine. So for example, if we wanted to test a restoration with a different basic website, if you're using Nginx as a server, for example, you would just change Nginx on your local machine and map that into the Docker containers Linux. Now, although restoration in the long term, it is something that's it is not easy. I mean, it's still difficult, and I still don't know how to test restorations when some factors like DNS or firewalls change, and because that could lead to a restoration failure. And it's hard to test for. It's hard to test for all cases of environment changes. Okay, it is 14:25. I won't go into too much detail of the implementation. Just to say, we used Golang to develop the module and a JavaScript for the test setup framework. This is just an example of our setting up the test. We just specify the database that we're testing, the restoration of, etc. That was just boilerplate code. I'll just go on to to start to terminate here. So obviously, for the approach to work, it means we want it to be usable by small businesses. That's why we insist on the automation aspect. But it means that every business be able to identify what is the critical data, what is its critical data that it needs to be ensure is always restorable. And this is something that only the businesses themselves can do. But now, in this post-GDPR world, it is something that the businesses have to be able to do, because otherwise, if they don't do that and client data is lost, then they can be fined. Okay, I didn't talk about how the snapshots are created. Okay, in our case, we were looking at Restic, which is a script framework for creating backups on Linux and Windows systems. But a more commercial system, for example, is Sure Backup, which is from Veeam, which allows data to be restored in a vSphere environments. And you can write scripts there. So the scripts rewrite could be integrated into Veeam from that point of view. What also is that when a company uses the framework, what remains is the tests. They always have the tests. So for example, imagine the company did lose data in a data leak. What the company can say is, hey, okay, these are the tests I was running. So, and these are how often I was running the tests. So the tests are sort of proof that the company is taking steps to test the restorations. And okay. And with respect to what we want to do now is that Basically, we're running our system on desktops. I mean, Windows, Linux, but of course, small companies are using mobile devices. I mean, telephones. How do we test restorations for mobile devices? We haven't treated encrypted data. If we do, it means that we're able to have access to the key, and also to the encryption key, and also to the history of encryption keys, so that we can do a restore from an earlier version. Another problem, I talked about regulation. GDPR is one regulation, but some companies, notably banks, also have compliance constraints that they have to conserve certain data over a much longer period, up to 10 years, when it's transactional data, financial transaction data. And in that case, you know, ensuring long-term data restoration is another challenge, because sometimes data is created by applications that go out of license, that no longer exist. Can you imagine somebody in a bank, they use a lot of Java, for example. Maybe they built a portfolio management application 15 years ago, which was using Java 1.4. Today we're Java 1.10 or 11 or so, and classes have changed, and there's no way you could run an application from that date on today's GVMs. So basically, there are a whole lot of can of worms issues for being able to restore long-term data, because you have to be able to test those restorations as well. And finally, other types of tests. There we were just talking about tests of restorability. But other type of tests you want to be able to do is maybe, is my data GDPR compliant? That means that if I give the name of some client, am I able to locate all of the data from that client? Am I able to erase data of that person without destroying the database? These type of questions we want to be able to test before. You want to be able to test the deletion of client data, you know, on the backup system without testing it on the production system. So that also is the subject of, that can be, it's the type of stuff that we can do perhaps in an automated way. Okay. And yeah, so that's it.